Hi everyone. My name is Andreia. I work at Datatonic, so I'm a data scientist. I thank you so much for the invite, first of all, to both Anne and the coding girls. I saw the program for the bootcamp. It sounded really, really interesting. So I hope you are enjoying it so far. Today, what I brought was something slightly different from the previous talk. So not so much about a specific GCP service, but more on how can we tackle a specific business problem with GCP. So this specific problem is how can we help Lush go packaging free? So packaging free being label free, all the wrappings and packages around their products in store. And they want to do it with ML. So how can we do this with GCP? So first, a couple of words on Ditronic. So Ditronic is a company I work for. We are partners with GCP. So this means that we help other companies migrate or accelerate their solutions in GCP. So sometimes our clients come from Google that forwards them to us. Other times they come directly to us, as was the case with Lush. So we specialize in three main fields, so data analytics, data engineering, and data science. I'm in the data science department, so I'm mostly focused in AI and machine learning. So let's take a look at the agenda for today. So I'm aware that it is already quite a bit late over there, or wherever you are in the world, but in Singapore at least. Here in the UK, it's still not yet midday, so I'll try to have energy for all of us. So for the next 15 minutes, what we'll cover is first, what is this problem that Lush was struggling with? Then how did GCP solve it? And some final notes on the deliverables. Around halfway through it, I'll stop for a bit just to see if anyone else has some questions I can address. If not, you can ask them at the end. And if you just remember your questions later, you can also use my email address. So let's kickstart. Yeah, so Lush is a company mostly everywhere now. They're specialized in beauty products and handmade cosmetics. So they're very famous for their bath bombs, as you can see here in the picture, very colorful. They are also very environmentally conscious. So they came to us with this idea of being completely paper and plastic free in their stores. So as you can see here in the picture, so no labels, no wrappings or packagings around their products. And they wanted to do it with ML. So I actually checked just to make sure that you guys would know what I was talking about. So there are Lush stores in Singapore. And so some of you may already been in a Lush store or know the store, or yes, so maybe this is an interesting use case for some of you or most of you. So Lush already had something in place. They had an image classification model outside of GCP. So it was only working for iOS and only working for 19 products. So our goal here was to improve what they had already. So we wanted to do something on GCP that would be compatible with both iOS and Android, and applicable for more than 19 products, because 19 bath bombs is not that much. Also, their image classification model was scoring a F1 score of 45. So out of 100%, there was still a lot of room to improve for sure. So on your right side, you probably noticed already, you get a glimpse of what this app is. So yeah, you just take your smartphone camera, you focus on the bath bomb, you wait a bit, it tells you the name of the bath bomb, and if you click on it, it will tell you more information like the ingredients and how to use it and so on. So yeah, this is the app. So how can we do it? So this is a very challenging project in terms of this specific characteristic, which is that it needs to be compatible with a mobile environment. So in reality, there are two ways that we can do this. So we can either have our image classification model in our smartphones, so in the app, the Lush app itself. And in that case, we rely a lot on the processor that we have on our smartphone. So that will affect the way that our predictions are either slower or faster. It will also take some storage space and drain a bit of our battery. On the other side, we can have our image classification model in GCP. So in that case, we'll rely a lot on the internet connection and how good it is to make requests to the model, right? So here, the call was really on Lush, and they decided to go with the first approach. So that meant that as a requirement, we had to build a very small model in terms of storage. And this call actually was made because they were not too confident that they could have a good internet connection in all their stores, so a good call. But yeah, let's see how we face this challenge. So let's build a machine learning pipeline to fix this problem. So in this machine learning pipeline, we need to account for four main things. We have a lot of images of bath bombs that we need to process to make them usable by the image classification model. We need to make a model in an automated way. So for those of you that are not so familiar with it, this model will basically give a lot of examples of images of bath bombs together with their names. And the computer will learn the patterns that distinguish each bath bomb. And then to evaluate it, we give like a set of images that the computer has never seen before. And we ask him to classify like, what bath bomb are you looking at now? So that's how we know how good the model is doing. But we want to do this in an automated way. So we want to make sure that this happens every time we have new bath bombs coming in store. And we also want to monitor and track the performance of the model, and finally to store old and new models for future records. So this is how the pipeline looks like. So we'll have our images of bath bombs stored in Google Cloud Storage. So that's our data lake. It's incredibly good to store all kinds of files. In this case, it was images, but it suits many different types of files. And it's compatible with all the other services in GCP. So really good for what we wanted. After that, we'll go into a data preparation stage where we get our images prepared to be used for the machine learning, by the machine learning algorithm, which needs to be compatible with a mobile environment. So our images, they were stored in Google Cloud Storage, and they were fed into a data flow pipeline. So this pipeline was mostly converting images into TensorFlow records, so that the model could then use the images in this format. So these transformations were done both in the train and the evaluation sets, which were then stored in Google Cloud Storage. So this step here. And then as an extra step, we had data augmentation processing, which is done in AI platform, because for that we need TensorFlow. So TensorFlow is a deep learning library that we wanted to use to do this data augmentation, and AI platform is compatible with TensorFlow. So that's why we did this step in AI platform. So data augmentation is actually a very cool technique because it allows us to have many different images from one single image, and we do this by changing saturation, brightness, cropping, or flipping the images. So let's take a deeper look at how we converted these files. So these files were converted into TensorFlow records, as I said, and these are basically numerical representation of the images, which makes it easier for the model to use. We did it in Dataflow because it is our fully managed service in GCP that specializes in these sort of data transformations. So in this case, we did it in batch. And because TensorFlow is so powerful in this horizontal auto-scaling, we could convert around 50,000 images in 10 minutes, which was really great, really important for the pipeline. And we couldn't do it without this horizontal scaling, for sure. So again, to the pipeline, let's look now at the machine learning step. So we both trained and evaluated our models in AI platform. So AI platform is our development platform to build machine learning models. And most importantly, it is compatible with TensorFlow, so the library we wanted to use to build our model. So we built our model, we converted it into TensorFlow Lite on your right side, top right. So this format is a mobile-friendly format. We did it as well in AI platform. And then we stored the models in GCS. So at the same time, we stored the evaluation metrics. So for instance, F1 score in BigQuery. And BigQuery here is our data warehouse, so no ops, completely serverless, very user-friendly, and that's why we used it to store our metrics. So you can now take a deeper look at the model itself. So as I said, we converted this model into a TensorFlow Lite format, which fulfills our requirement to have a small model, which is great. So it now takes 3.5 megabytes. We also applied some more advanced techniques on top of it, like quantization and transfer learning, which makes it easy to have a performance model in these conditions. And as a result, we have a model which works both in Android and iOS. We improved greatly the F1 score from 45 to 97, which is really good. And it now works for more than 500 bathrooms. So coming back to the pipeline, if you still remember, we wanted to do this as automated as possible. So to do this, we used Composer. Composer here is our framework for scheduling and to create flows of tasks. So for instance, here we have the image ingestion, then followed by the data preparation, then followed by the machine learning step. And each task here will only happen once the previous task has been successful. So here we can see the full pipeline. The way we automated it was on a scheduled basis. So weekly, the pipeline will check if there are new images of bath bombs. If indeed there are new images, it will run the next steps, so all the pipeline. If not, then it will stop there and won't run the rest of the pipeline. Yeah, and these are the deliverables in a nutshell. If you guys want to actually take a look by yourselves, the app is available at the App Store. And actually, Lush has two apps. So the one that has this functionality is the Lush Labs App. And yeah, if you go to this app under the Lush Lens banner, you'll find this functionality. You can give it a try inside the stores if you feel like it. So yeah, so far, any questions? I think there are some comments here on the comments page. So yeah, one of the questions was if the uploaded images are stored in GCP storage bucket. Yes, yeah, they are. So we have a bucket for these images, and then we have a bucket every time we saw the GCS being mentioned in the pipeline. We have a different bucket, so we don't mix our data. So after Dataflow works, yeah, and during AI platform works as well, we have all the data organized in different buckets. So is the accuracy of the app to identify the product subject to end user's phone capability? So my understanding is that if the accuracy depends on the phone, it does not. What will be dependent on the phone is just how fast it will give you the prediction, really. So it depends. Like if you have a more powerful phone, it will process things faster, a bit like it happens with any app, really. But the accuracy won't be depending on it because the model is the same for every phone. But yeah, let me know if this was not the question you had in mind.
I think the question may be related to like the image quality, where that matters to your model.
Oh, right. Yeah, the picture quality. Yes. So each image that you take will be a new input to the model. Also, more than the camera capacity, it also depends on the background. So if you're holding it, if you have a lot of noise in the background of the bath bomb, it will make it harder. So as a threshold, like if the model can't predict something with more than 99.9% of accuracy, it will give you the first three most likely bath bombs, if this makes sense. So it's actually something that we can see here. One of the examples shows that the model was not too confident in the first prediction. So it just gave two, and yeah, you see here. So it was not too confident on what it was looking at. So we will give you 1, 2, or 3 options that the user can then pick. And it probably be easier for the user to understand which one of the 3 it is. So I think, yeah, we had some slides on the processing here. I don't want to be lying to you. So yeah. So this was related to explaining the quantization and why it matters, because using this technique improves how fast the model will perform. So it depends also on the internet connection, but it is in the range of milliseconds.
There's another question. Is there a particular reason you store the trained model in Google Storage, on Google Cloud Storage?
Yeah, so we didn't actually serve the model. That's why the model is not, say, saved in AI platform. We don't need to do it because we'll be using it then on the phone. So this will then be connected with the Lush app. And that's why we just needed to store it somewhere cheap with good regional coverage as GCS, so that it would be easier to then connect this to the Lush app. So once the model is there, it will be used on the app in frozen mode. So it's not that we are connected to a dynamic model all the time. So every time we need to change the model, we actually run and build another model and save it in GCS to connect to the app.